Welcome to Sonny's, the car wash factory. In conjunction with this training video, please reference each component's owner's manual, available at sonnysdirect.com, before performing any installation, repair, or maintenance procedure. Each manual details specific requirements and settings necessary for the safe operation and maintenance of your car wash equipment.
Hi, welcome to Sonny's, the car wash factory. Right now we're going to take a look at our wraparounds. Wraparounds have a very complex piece of equipment. There's a lot of little adjustments to make that make them work really well. We make them both in hydraulic and electric. Today we're going to look at a set of electric wraparounds that'll have a couple less service features, but they are a little bit heavier and they act a little bit differently than our hydraulic wrap. So we're going to go through some of the settings and some of the constant checks that you have to do to make sure that your wraparounds are in good working order. At first, I want you to just see where they're resting right now. They're resting all the way wide out, fully retracted, okay? And that's the way they should be when the conveyor's not running. The safest way to run the wraparounds are to keep them retracted. They'll only turn on when the conveyor starts for safety in case we lose air pressure when they come in front of the car. They'll wash properly, okay? And they'll be able to move out of the way. They're also interlocked with the conveyor, so if we start the conveyor, they run. If we shut the conveyor off, they stop. That's the way we like to have them running. These here are, again, retracted. If we turn the retracts off, which we'll do in just a minute, they should come to the center of the vehicle, ready to wash the car, even without them spinning. The rotation of the brush helps them come home. If they don't do that, there's a couple of checks we have to make to do that. So right now, I'm going to actually let Robert in the back room activate the retract switches and let the brushes come in so we can see that they will come in all the way or won't come in all the way. So here we come. And those there did exactly what we wanted. And one of the ways that we run our wraparounds is we put a little bit of air pressure on the backside of the wraparounds. And that's what helped these come all the way home. That little bit of air pressure that keep the wrap washing the car properly depending on the chain speed. This conveyor is running about 125 cars an hour. So we've got about 10 to 15 pounds of air pressure on our passenger side because the arm is longer, and probably between 5 and 10 pounds on our driver's side. And that little bit of pressure helps that come home real quick, but it also balances the RPMs against the wash impingement on the vehicle. And we're only looking to wash with about 3 to 4 inches of our cloth fingers against the car. And that's how you balance these out. It's RPMs, wash pressure, makes it a nice safe contact with the vehicle. It doesn't bounce off the car, it stays with it, and that's what makes it work. I'm going to ask Robert to turn off the air and exhaust it all completely so we can see if the brushes are aligned and level, that they will come home without that air pressure. So right now I can hear him clicking the exhaust valves over there, and the air is off. So if I push this brush back right now, it was nice and easy to push back. If I let it go, just based on its alignment and the shock absorber, it came home to the start position. We'll test the same thing with our driver's wrap. We'll let it go and see if it comes home. And it comes home okay. The cloth over here touches the conveyor a little bit, so that's the only thing holding it up. We do have two different shock absorbers. When you look up top, you'll see a red shock absorber on the driver's side because the arms are a little bit shorter and they don't take as much pressure. On the long arm on the passenger side, it's a white shock absorber that has a little bit more extend pressure. But right now, these wraparounds here are set up quite nicely. They're both coming home pretty easy, and that's exactly what you want. If they weren't coming home, the first thing we want to do is check to make sure all of our air is exhausted. The regulators we use are exhausting regulators. If you happen to have a service problem and you change them, you want an exhausting regulator. So as soon as you switch the flow, the air should exhaust completely, and it lets it work basically on its own. If you really want to check everything else out, we can go up top, we can release the air pressure, pull the pins, and like I said, the shock absorbers are gas-powered shocks, so they're always going to try to extend. If, when you take it apart, it doesn't extend, it's actually lost its gas, or the bladder has been ruptured, it'll just be stationary wherever you put it. That's an indication that your shock is bad, we need to replace that. And that makes a lazy brush. If the air cylinder is having a leak or a problem, it's not getting its right control, you'll be able to see that as well if it's binding, if there's any contamination on the shaft or a bad seal, you'll be able to pull that in, push it out, and be able to identify if that's the problem. We're going to go up top now, and we're going to do a couple of, show you how to do some adjustments on the spring stop, show you how that works. I'll actually show you from down here where it's attached now, and then we'll talk about the bearing adjustments and the bearing greasing. But if you can take a look up top at that bumper stop attachment, when I push this brush in to come home, it's a spring-loaded bumper stop. So it takes a lot of the cushion off of the vehicle and off the frame of the machine, It makes a nice soft motion when it comes across the back of the vehicle. They both do the same thing. The driver's side and the passenger side do the same. And you can also look up there and you can see that there are 3 hold positions. We set them off in the center holes whenever we ship them out. And we do that there because at that point when they're in, we can see from here, we've got about 6 or 8 inches of overlap at the front of the vehicle. Some locations that don't have license plates at the front that may want to get more aggressive, we recommend only moving 1 brush in on one side to get a little bit more action on the front of the vehicle. It could be the driver's side or the passenger side. I will show you how to do that adjustment as well. Real easy to adjust the bumper stops. Again, like we said, they're in the middle position when we send them out. It's kind of neutral. Gives us some good wash penetration on the front of the vehicle. Stainless steel spring pins, pull those out and release them. And those release these 2 pins here. All we do is push these up, take them out, and then this bumper assembly can be pulled out another inch or so. And we can actually make it less aggressive on the front of the vehicle if we'd like. And it'll hold our unit out a little bit further. If we want to have some increased pressure against the vehicle, we slide these out again, push our bumper in, and come in here. And we've actually brought our brush closer. Okay, we've shrunk our little spring assembly, but we're letting the brush come in a little home now and get a little bit more action in the front of the car. Again, if you want to be more aggressive, I would recommend only moving 1. More likely you want to move the one on the passenger side because the vehicles are all different widths, and that'll help you get a little bit more impingement. The driver's side, because of the conveyor rail, it's always reaching the same spot. It's much easier to move the passenger side, and the long arm is more friendly. I'm going to put this one back in the center because I think in most of our situations, that's where it works the best. And we've been running some test cars here, and it's been doing really, really well. So we'll put it back here in this position. Put our spring pins back in place. And that's how you adjust your bumper stops for more or less penetration on the front of the car. Now, we mentioned a minute ago about the wash pressure on the side of the vehicles. We have a chart on the manuals and on the web where if you're running a conveyor at 80 car chain speed, we want to run the brushes at about 70 RPMs, and we want maybe 0 to 5 pounds of pressure washing the car. When we go up to 100 cars an hour, we increase the RPMs and we increase the pressure. We go over 100 cars an hour, we increase it again. So we can get up to 85, 90 RPMs, and we can get up to 20 pounds of pressure chasing the back of the car and staying on the side of the vehicle. In some extreme cases, if you've got a great site that's washing in excess of 150, 160 cars an hour, 180 cars an hour, some guys would like to get this brush a little bit more aggressive. And just air pressure alone is not going to do it because the RPMs are so great that it's staying off the car, washing the side real nice, but doesn't load up on the back. So a way to get a little bit more action on that there is to actually adjust the bearings. And the bearings will put a little bit of pitch in the arm, make them a little bit heavy, and they can actually chase the car really well. I only recommend this at speeds well above 150 or 160 an hour. The way to do that is to come over here to your bearings. The bearings are set up, they're double tapered roller bearings. They've got jack screws to hold them in place. We've loosened these up so it'll be a little bit easier to show you here on the video. But if we only move one bearing, we don't have to touch the other ones because these bearings can handle up to 3 degrees misalignment. We can loosen up the bottom bearing, and to make this passenger side brush aggressive, we want to move this bearing 1/8 of an inch to the wall on the passenger side. So on this one here, we've already loosened up the bottom bolts. I've got my wrenches up here. When I want to move this over and I want to move it to the wall, I loosen up my bolt on the left-hand side here, and I move it to the position I want to set it at. So I'm going to just crank it back 1/8 of an inch. I'm going to bring it back here and just tighten this up a little bit. Then I'm going to come to this side, loosen up my inside bolt. And then use this bolt here as a jack screw, just like it's called. Actually, you know what? I'm going to help me with this here, I'm going to actually have him take the air pressure off. The weight of that arm, when it's retracted all the way, puts a lot of pressure on the screw when I'm trying to push almost 300 pounds all the way over to the left. So by bringing it home, now I'm more neutral, and I can actually take this And now I can move this bearing. If you look up close, you can see this moving over. And I want to bring it all the way up until it touches my bolt on the other side. It gives me that 1/8 of an inch of movement. Okay, tighten that up. And then we can test it again by having him hit the retract button again and letting it come back home. And we'll actually see this, how much quicker it comes into position. All right, so we're gonna have him retract this brush again now, and then let it come in with pressure on it. You'll see how much quicker it comes in, even probably enough to compress our shock. Okay, let's bring it in. And now that comes in kind of heavy, and you can see that even the spring got compressed a little bit. So if we were washing 150, 160 car chain speed, this would wash the back of a van, a truck, or a car, as well as it was on an 80 car chain speed at 70 RPMs with 5 pounds of pressure. So the brushes are really infinitely adjustable. We can fine tune them to wash the speed you want to wash to get the cars clean the way you want to clean them. It's real nice to do. Again, I went 1/8 of an inch. 1/8 of an inch on this brush here is a lot of cleaning power. It's a lot of pressure. If you do this without speeding up the RPMs of the brush, you'll be too aggressive on the side of the car. So there's a marriage. The scale is in the book and on the web. Read the scale, look at the speed of the conveyor, the RPM of the brush, and then the wash pressure. And at the worst case, the very last step is to give this a little bit of lean or a little pitch into the vehicle to make it a little more aggressive. All right? I'm going to reset this one back to where it was. And then we'll come back and we'll take a look at the RPMs and how to time the RPMs. On the wraparounds, depending on whether they're electric or hydraulic, both sets of wraparounds have pivot bearings on the arms and the back. Again, pivot bearings are once a month. Again, these are our double tapered roller bearings, which there's 2 tapered roller bearings in there. They give you two grease fittings, more for accessibility. You only need to grease one. And again, a pivoting bearing, which is on a non-rotational, is only once every month. And it's going to get 2 shots of grease. So we'll come up here, we'll give this 2 shots, we'll come back and wipe the grease off of that one there. We'll go up top here, catch the top one. Get 2 shots in there, we'll come back and wipe that off. Again, 2 on each arm. These are electric wraparounds, so they don't have any rotational bearings on the arms, on the brush assemblies, because they work off of the bearings within the gearbox. If they were hydraulic units, they would have 2 rotational bearings, just like a top motor brush. So all of our top motor brushes are the same, electric or hydraulic. Some have bearings, some don't. If they're there, once a week greasing. On the gearboxes, other than checking the gearbox oil and looking for leaks, there is no other real maintenance there. The motors are wash-down duty motors. We don't even grease them. They stay just the way they are. Okay? We're going to come down now. We'll take a look at how we set the air pressure in the back room for both retract and wash pressure. And we'll also check the RPMs of the brush and show you how to adjust those as well on an electric drive unit.
All right, so what we're looking at here is the VFD variable frequency drive for the wraparound washer. This is what's controlling the wrap speed, as you saw out in the tunnel with Anthony. These work off of hertz. The higher the hertz, the faster the RPM of the brush is going to be. The lower the hertz, the slower the brush is going to spin. To adjust the speed with the VFD, this particular one just has a little knob here. To increase the speed, you start turning it backwards. And what you'll start to see is that the hertz will go down. As I do this, the brush is going to slow in speed. If I go all the way down to 0 hertz, essentially what that means is the brush has totally stopped spinning. As I increase this, the brush is going to slowly pick up its movement. I can go ahead and peg it, and it'll take a minute for it to go all the way up to 60 hertz, which is going to be the maximum speed. For this particular brush, we found that it was running nice right around 55 hertz, so I'm going to go ahead and lower it back down to right about 55 hertz, where we found it to be working rather nice. Okay, so what we have here is our 4-way MAC valve. The 4-way MAC valve is what's going to control the movement of the wraps in and out. This MAC valve is going to be responsible for movement, not only wraparounds, but any other piece of equipment that has to move in and out in the car wash. It's a 4-way valve. You've got your main air coming in through here. This is what's called our normally open port, meaning that it's always going to be flowing air through this bottom line, whereas that's where we set our retract pressure, which is going to be set right around 50 psi. That's what's holding the brush out towards the tunnel walls. We have the normally closed side of the MAC valve. When the computer energizes the normally closed side, normally open side is going to go to the normally closed side. When we do that, the computer will change the way the air flows, and then we'll have our wash pressure for our wraparound over here. We can increase the pressure by turning this valve here. The amount of pressure that's going to be required for the wraparound is going to determine on the speed that your conveyor is running.
So now we're in the car wash tunnel with the wraparounds, and we just want to talk about the RPMs of the wraparounds and then how they move up and down and what the new material looks like as it's on the brush and shaped. Because as it wears out and you look at it every day, it's hard to notice, but you want to put this in your memory. Remember what your new equipment looks like when it's new, so you know when the cloth is worn out. But right now, these wraparounds are probably spinning in the neighborhood of 85, 90 RPMs. These are electric drive wraparounds, so they're driven by a variable frequency drive in the back room. If I ask Robert to slow these down, he's going to basically turn the dial on the drive and bring the frequency of the hertz down from where it may be 55 or 60 down to 35 or 40. And that's both sides now. You can see how they're both slowing down, and they're independently operated because there's two different drives for each wrap. But this here is how you get it down to about 50 RPMs. And then Robert will bring them back up again, and we'll get them up to about 55 hertz maybe. These gearboxes up here are 20-to-1 gearboxes. So basically on an 1800 RPM motor, it means we can run approximately 90 RPMs. We don't need to go quite 90, so we'll set it at 55 RPMs. And then we're going to go back and attach a little piece of wire or tie wrap to one area. And again, we can time this out. We've done this on a couple of side brush videos, but basically it's the same. We'll put a piece of something on there that we can count as it spins, and we'll time it for 10 seconds and multiply it times 6 and find out how many RPMs we have a minute. So I'm going to have him shut this down. I'll attach this little piece of wire to one of the cloth materials, and then we'll start it up and time it again. So again, we've got this running at 60 hertz. We'll time them out. They should be close to 90 RPMs, and then we'll see what we want to adjust from there. Okay, and Robert's going to help me on the stopwatch because it's going too fast for me to do it alone. Robert, you say when.
Ready, set, go.
1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 RPMs. That puts us right at the 90 RPMs, right? So we don't want to run these at 90 today. I think we're going to be looking more for is an 85 RPM for this car wash. So let's ask Robert in the back room to turn this down to, say, 55 hertz. And we can see we got a little change there. Have we got a confirmation for 55? Okay, then let's give it another count.
Go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 RPMs. 14 times 6 will give us about 80, I think 84, 85 RPMs, right? 84 RPMs. So that's about where we want them. So we're going to have Robert set the driver's side also at 55 hertz. And again, this is our Durasoft material, which we run the same as NeoGlide. So we'll go back and set our front set also at 55 hertz, and that's how we're going to start this car wash off. So if we need a little more cleaning power, we know we've got 5 more hertz to go. And if we have to even go past that, if this becomes a great success, we can program that VFD to take us even to 70 hertz or 80 hertz, and we can push this a little bit faster. So we've got a little bit of flexibility there, and it'll really help make this car wash be able to be dialed in at its maturity to make sure the customers constantly get a clean, dry, shiny car. So again, if this was hydraulic, follow our instructions on adjusting a hydraulic brush, like a tire brush, like a conveyor, and basically you're turning the brand valve from, the setting is from 0 to 10, and it's basically the percentage of gallons you're using, but the closer you go to 10, the faster you go, the slower you go down to 0 or 1 is the slower you go, and again, put a little something on it, run it, count the RPMs, multiply times 6 after 10 seconds, and you'll set your RPMs just the way you need to get a clean and shiny and very safe wash operation in your own car wash. I'm going to pull that wire off before we wash any cars and do any damage, and that's it. Thanks.
Thank you for watching this maintenance overview video. Please visit sonnysdirect.com and review the complete owner's manual before attempting any installation, maintenance, or repair of this component. There you'll learn necessary procedures, settings, and other considerations required for the safe operation of your car wash equipment.